Assalamualaikum. I am Rafiul Islam from team The Underdog. This is RoboFusion 1.0 multi-hazard smart campus safety and response grid. Our system monitor 5 university lab in real time, detecting fire, gas leak, flooding, and occupancy using sensor fusion. The architecture work like this: a Wokwi ESP32 zone node and raw sensor reading on our backend. The backend run RIX fusion formula to compute a score, store it in SQLite, and push live update to this React dashboard. And the zone node never decide its own state, all intelligent in server right. Here backend is running on port 3000 status online monitoring 5 zone. This is test case 8, the get slash API slash v1 plus slash zone endpoint. Every zone return its current state, actuator status, risk breakdown, and ML prediction all in a single response. Look at zone Techathon chemical synthesis lab. It's in working state. Warning state, and the current risk score object show the individual score: fire 8.8, gas 28.5, water 1.6, occupancy to total score 40.9. The score was computed entirely by the backend using our risk fusion formula. This is test case 6. The zone node never sent a pre-calculated score; it only sent raw sensor value. All computation happened server side. The ML prediction block is separate from the live risk score. Predict score for 30 minutes ahead, probability on upgoing critical trend direction, and clearly labeled, never used for physical trigger. Now this is the get slash API slash v1 slash incident endpoint. Full incident history with timestamp, trigger reason, and resolution detail. Inside incident in 1921 in the chemical synthesis lab, triggered by solver gas concentration exceeding threshold plus high PIR occupancy. Risk score peak at 68.5. Acknowledge and resolved by security staff Sarah Corner with a resolution note. Logged in 1980 thermal runaway ignition. Spike at 110 in the battery test cell. Risk score 54.2. Same step acknowledged with force exhausted. Same step acknowledged with force exhaust fan activation. Logged as action taken. Every incident has a complete audit trail. Who responds when and what action was taken. So this is test case 20. The live zone map. Each zone tile show both a color indicator and an icon, not color alone. This ensure usability for color blind user. This is test case 16V. Red means critical, yellow means warning, green means safe, and icon reinforce the state visibility. Now the priority query rank zone by urgency using a combination of risk score, occupancy count, and time lapse. The highest risk zone appear at the top. Responder immediately know where to go first. This cover test case 20V and 20C. Now triggering at anomaly. Now watch the dashboard update automatically without any page refresh. This is test case 20A, real-time live update via WebSocket. This is test case 22, end-to-end multi-zone incident. Two zones have elevated risk simultaneously. The backend compute each zone risk score independently and rank them in the priority. In the priority query, responder can see at a glance which zone need immediate attention and which can wait. This is the core value of our priority ranking system. Acknowledging the higher priority zone, test case 22, step 4, staff select the zone, log the acknowledgement. Both incidents are now logged with full timestamp, zone detail, and staff information. Test case 22, step 5, the audit trail is complete. This is test case 13, role-based access control system, currently logged in as security staff. Our system has 3 roles: admin, safety officer, and security staff. Security staff is with a different permission. Attempting to access the admin threshold to configuration panel as security staff, access is denied. The panel is not accessible and the option is not available to this role. This is not just UI handling. The role validation is enforced at routing level. Security staff can acknowledge incident and view all zone but cannot modify safety critical system parameter. Only an admin can do that. If possible, then switch to the admin account. Now the threshold configuration is fully accessible, same endpoint, different role, different access. This is test case 13, server enforce RBAC. Now demonstrating test case 23 is case sending invalid sensor data to the backend. Run the command in the PowerShell. In negative water level, physically impossible. The backend immediately reject each invalid raw value. For sensor level -5 must be a non-negative number. Invalid data is never accepted into the system. This is S case false invalid value rejection. And now stop our backend and restart our backend system. Now demonstrating S case E backend resilience restarting the server completely. Now refresh our dashboard. After full restart, all zone state incident history is fully restored from the database. No data loss, no manual recovery needed. This is also test case 9 backend resilience. This is test case 26. The circuit diagram zone node simulated on Wokwi ESP32 with real component behavior. Save state. The green LED active, all reading normal. Now warning state yellow LED gas concentration elaborated above fast threshold. Now critical state LED red LED and buzzer active, fire confirm, immediate alert trigger. Test case 1 fire detection, fire debounce logic. The flame sensor require fiber consecutive high reading before confirming a fire event. A single flicker or transient noise never trigger a false alarm. This prevent panic response to sensor noise. And this case 2 gas sensor warm up. So warm up suppression for the first 30 seconds after boot. All gas reading are suppressed. MQ series gas sensor have unknown warm up period. This prevent false critical alert on startup. This is our bonus feature 3 ML risk prediction, a logistic regression model trained on synthetic sensor history. Predict zone risk 30 minutes ahead. This predicted score panel is clearly separated and distinctly labeled from the live risk score. No confusion possible between prediction and real-time data. Most importantly, the ML prediction cannot trigger any physical actuator. No relay, no buzzer, no sprinkler. It is a decision support tool only. All safety critical action remain with the deterministic backend logic. This follows safe AI integration in practice. Now, one more time, we see our API/v1/incident page, our SQLite database infos, referential integrity. A zone cannot detect it while it has open incident. Unique constant and acknowledgement ensure that our concurrent instruct response create only one record. Queries on incident are optimized using a composite index on status and timestamp. Fast retrieval without full table scan. That's complete our demonstrations, submitting our GitHub repository, full documentation PDF, and this video. Thank you, everyone. We team the Underdog RoboFusion 1.0.